So for number 22, a race car starts from rest on a circular track of radius 400 meters. The car speed increases at a constant rate of 0.5 meters per second squared. Now, please notice that this is a regular tangential acceleration. At the point where the magnitudes of the centripetal and tangential accelerations are equal, determine A, the speed of the car, B, the distance traveled, and C, the elapsed time. So, we know the tangential acceleration is 0.5 meters per second squared. We want the magnitude of the centripetal acceleration to be the same quantity. So that means it's also going to be 0.5 meters per second squared. But we need to figure out the speed of the car. To do that, we can use v squared over r because we know the centripetal accelerations can be 0.5. We know the radius of the circle is 400. And if we plug that in, you'll get v squared is equal to the square root of 400 or 14.1 meters per second. So that's the answer to A. For part B, what distance did it travel? Well, you could use a bunch of different equations, but since we don't have time yet, unless we did C first, I'm going to use this old equation. And we're talking about linear motion, or really just linear velocities, linear accelerations, or tangential. So literally just plug and chug. Starts out from rest, that was given to us up here, and its final velocity needs to be 14.1. We know it's accelerating as it goes around the circle at 0.5, and we can solve for delta x. And you can sort of very quickly see here, 14.1 squared is going to give us back the 200. 2 times 0.5 is 1, and so delta x is going to be 200 meters. Finally, for part C, the elapsed time, you could use a bunch of different equations for this point. We've got time, we've got acceleration, we've got velocity, initial velocity. But I'm going to try to choose the simplest one. Final velocity equals initial velocity plus acceleration times time. In this case, we know it starts off from rest, gets up to 14.1. We know it's accelerating at that rate. And so the time is going to be about 28.3 seconds. Good luck.